Okay, so now we're going to do a little brief discussion of the properties of matter. Not much in the way of calculations here, so we'll just go through some little details here. So when we talk about properties, properties are things that we can observe about a material. So for example, suppose we found this rock and we noticed that it had certain appearances, right? There's appearances to it. So it's important to note that we could consider qualitative properties. Qualitative properties would be, is it hard or soft? Is it light or heavy? Right? Is it hot or cold? Is it red or blue? Those are examples of qualitative properties. They don't have any numerical value associated with them. On the other hand, we could make quantitative observations, quantitative properties, such as what is the value of the density? The density is 4.2 grams per centimeter cubed. That is an observation about the rock, but it's a quantitative observation about the rock. We could say that the temperature is 297 Kelvin. That is a measure of the temperature. Remember we said in the previous section, a measurement involves a number and a unit. Well, there's a number and a unit. That's a quantitative observation, a measurement about that rock. We could say that it absorbs light from 200 to 250 nanometers. That's a quantitative observation. That's a quantitative observation. We have numbers associated with it. We're making a measurement about that rock. Okay? So that's the issue of qualitative or quantitative. Now, it's also useful at times to consider what are called physical properties versus chemical properties. Okay? The fundamental difference between physical and chemical properties is whether you are permanently changing the substance. If you permanently change the nature of the substance, of what it is, then that's a chemical change. If you make a measurement on something and you don't change the nature of what it is, then that's a physical change and you're measuring a physical property. So for example, let's consider the boiling point of water. Here's what happens. What happens with boiling water, remember you have this container, you've got liquid water in there, and you're adding heat to it, right? There's a little burner, we're adding heat to it, we're going to boil it. Eventually it turns into a gas, it goes into the air, it escapes as a vapor, right? But what is that vapor? That vapor is still water. It's still H2O. Okay? So the physical change, or the change that's occurring, is a physical one. So the boiling point is really a physical property of a substance. Water boils, the normal boiling point of water is 100 degrees C. That's a physical property of water. And the physical change is the process of it changing from a liquid into a gas. Okay? So physical changes such as boiling, Melting is another example. When we melt water, it's still water. It's not turning into something different. It's just its appearance is different. Its physical properties, its hardness is different. Its viscosity, for example, changes. Maybe its color changes, but it's not inherently changing the substance into something else. So that would be another example of a physical process. Now, chemical, on the other hand, a chemical change involves really changing the nature of what something is. So, for example, if I have water inside this container, and I dissolve a little bit of salt into it just to conduct electricity, and then I put in 2 electrodes that are attached to a battery. Okay, so you attach a battery to it and turn the battery on. What you'll find is that some substance will be released, a gas, which is oxygen, and another gas, which is hydrogen. And that's coming from the water. The water is getting converted into, I'll draw a little arrow to represent this, into hydrogen gas and oxygen gas. So it's no longer water, right? This one is water. So is that a chemical change or a physical change? There is some physical things happening, right? It's getting converted into a gas. That's a physical change. But it's actually decomposing into 2 different substances. Hydrogen is different than water, and oxygen is different than water. So this is a chemical change that's occurring. So what we would say is that electrolysis of water, breaking down water into hydrogen and oxygen, is a chemical property of water, that it can be broken down into hydrogen and oxygen. Okay? If you even go back to that original rock, if you crumple up that rock, you're changing some of its properties, right? It's now little pieces, you've pulverized it. But each of those little pieces is still a rock, right? It's still a rock. Whereas hydrogen is not water. They're different substances. So chemical changes and chemical properties really tend to be an issue of whether you're changing the nature of what something is. Okay? So let's take a look at one more aspect of this section, which is that of identifying properties as being either intensive or extensive. Intensive properties versus extensive properties, okay? So intensive properties do not depend on the amount of material. Extensive properties do depend on the amount of material. So let me show you an example of that. If you take that rock, you shave off a little piece, you cut it off. Okay? The color of that rock shouldn't change, right? Meaning if I have a small piece of the rock, the color is going to be the same as it would be if I cut off half of it. Now, obviously, you can imagine rocks where that wouldn't be, but let's just assume the color is uniform. So color would be an intensive property. Now, it turns out that's not exactly true. You know what's interesting? If you take a piece of gold, block of gold, it has a gold color. If you pulverize it into little tiny particles called nanoparticles, You know it turns red? It actually has a different color if it's made of really, really tiny particles in the nanometer range, 10 to 100 nanometers. So in fact, color in some sense, our definition breaks down at some point. But for a good-sized rock, if we took one piece or a smaller piece, the color doesn't change depending on how much we have. Therefore, we would call that an intensive property, the color of something. Another example of intensive is the temperature. If I have this whole rock and I measure its temperature, 280 Kelvin, and then in the same room I take a small piece of it, we should get the same temperature. Temperature shouldn't matter how much of the rock you have. It should be the same. So temperature is an intensive property. It doesn't matter how much of it we have, it's an intensive property. Let me show you a couple of extensive properties. Sorry, let me respell that. I'm going to try to draw a little scale here. Okay. If I put a little piece of the rock there, it might weigh 10 grams. If I put a big piece of the rock there, it might weigh 50 grams, right? So it seems to matter. The mass of something seems to depend on how much of it you have, right? Of course, that makes sense, right? The more of something you have, the more it's going to weigh. So this is an example of an extensive property. So mass is extensive. Depends on how much you have. Same thing if you're measuring out water. The volume might be 10 cubic centimeters. If you put more in, might now be 30 cubic centimeters. So the volume depends on how much you have. The more you have, the larger the volume is going to be. So that's another example of an extensive property. But interestingly enough, if you take the ratio of something and you divide it, the mass by the volume, turns out this is intensive. So even though the mass is an extensive property and the volume is an extensive property, the ratio is intensive. Isn't that interesting? That sometimes happens. When we do a ratio, we can turn extensive properties into intensive properties. Now, why is that the case? Well, here's what happens. If you only have a little bit of water, it's only going to have a small mass, and it's only going to have a small volume. So these are both very small. But if you fill up more of it, you have more mass, but you also have more volume. So these both increase by the same amount, essentially. They increase at the same, to the same degree. So this is the density, of course. The density is an intensive property, right? Doesn't matter how much water you have, it's going to have the same density. If you have an ocean, it has a density. If you have just a little pool, it'll have the same density, even though the mass and volume are different.